Today I'm doing something different than I've ever done today. I'm gonna push this further than I've done with any other class because I feel like we can. This is always the day where we pull everything together from the first half of the semester. And so far we've done a lot of stuff, right? We're not going to do latent class analysis stuff, but we are going to pull together everything else that we've done. So we have done path analysis and we've looked at model fit. We have done interactions and probing interactions. We have done indirect effects and calculating indirect effects in M+ using model indirect. And we have done conditional indirect effects, which is calculating indirect effects as a function of some sort of moderation, right? When we have both mediation and moderation together. We have done latent variable modeling, and we have done factor analysis. And today we're going to take all of those things and put them together. We're going to do factor analysis, then we are going to use that factor analysis to form a structural equation model. Then we are going to look at the indirect effects from that structural equation model. And then we are going to learn how to do interactions with latent variables. And finally, how to probe interactions with latent variables and calculate indirect effects with latent variables. So we've got a lot on the plate for today. Am I recording? I think I'm recording. I am recording. So is everybody ready? Everybody have their data downloaded in their input file ready to roll? Okay. So when we sit down to do a latent variable structural equation model, the first step in that process is to do a measurement model. And so for our measurement model, we have 4 latent variables for today. We are going to be looking at good self-control, poor self-control, alcohol use, and alcohol problems. And so for starters, let's just have a look at a measurement model. Let's build our measurement model. So a measurement model is what? A CFA of our latent variables, right? So we're gonna, here are the variables that we're gonna be using, and I will walk you through them. These are all alcohol problems. So we have 7 different types of alcohol problems. We're gonna use those to construct a latent variable for alcohol problems. Then we have problem solving, planning, good delay of gratification, and future time perspective. We're going to use those to form a latent variable of effortful control, or good self-control, I like to call it. I'm a dual process model person, which means I like to talk about self-control as these 2 kind of separate things, right? Kind of like a gas pedal and a brake. Then we have distractibility, poor delay of gratification, present time perspective, and impulsivity. That is poor self-control, or just impulsivity if you rather. And then we have alcohol use. Number of drinks that you have, your drinking history, and drinking frequency. We're going to use those to form a 4th latent variable. So estimator equals MLR. Do you guys have this in your file? Does it say type equals random algorithm, blah, blah, blah? Okay, good. Don't worry about that for right now. So we're going to start with this, right? We are going to make a latent variable model with good self-control, poor self-control, alcohol use, and problems. So go ahead and make your measurement model. And after we make our measurement model, are you confused? You guys look confused. What are you confused about? What's that?
You're talking about like that model?
Yeah, yep. All I'm saying is copy what I already put there. So we have 4 latent variables, right? We have good self-control, poor self-control, alcohol use, and problems. And good self-control is a latent variable that is constructed by those 4 indicators. Poor self-control is a latent variable constructed by those 4 indicators: alcohol use, alcohol problems. Did it run? Who ran it? Anybody run it yet? Who's thought about running it?
I consider it. Yeah.
You don't have to worry about any of that other stuff.
Because it's not deactivated in our code. Does it make a difference?
Wait,
Process
th-
equal
th-
to,
is process listed in the code that I gave you?
yes, it's listed.
Oh.
It's not taken out.
You can run it or not run it. All that does is it says use, if you have a dual process core, then it's just saying to use both cores instead of just one core. So, yeah. You got an error message.
Warnings and errors. Let's see.
You will get some warnings. If you get an error message, then that's more problematic.
Yeah, error.
What's the error message?
Oh, this has to do with the file. So, the name of the file. I think this is a problem that I'm having. Yeah, I know how to fix it.
I might not have changed the file location or something along those lines.
When I downloaded it, there was
Yeah.
class-1 on one of the
Exactly.
files, so they were.
Ah, gotcha. Okay. Yeah, you'll have to make sure that it's named what it's supposed to be named in there. That's probably because of something I did. I think I had the wrong input file in there, or maybe the wrong data file. Anyway. What happens is sometimes I upload a data file, I will name it class, and I will do that across. And then when I go to upload class again, it rewrites it to class-1, class-2, just because I have too many of them saved in my, it saves all of my stuff, right, for one class over and over and over in the same kind of folder. And so anytime I add a new data file, it might be like 3 years ago, I had one called class, and it changes it. I'm sorry. We should probably go in and figure out how to delete that stuff. Who was able to get it to run? All right, cool. What does the model fit look like? Awesome, you say? Not awesome?
Acceptable.
Let's have a look. Is this what everybody else got for model fit? Did you guys get 488 for chi-squared, 129 degrees of freedom, RMSEA 0.072, that's not terrible. CFI 0.913, that's okay. TLI 0.896, that's okay. SRMR less than 0.06, that's okay. Somebody else got something different?
Mine's like slightly different than yours. I have a different degree of freedom.
You did something wrong then.
You had 30.
What's that?
There's some list statements that you have exclamation points and mine didn't have.
Oh,
I added those.
oh, don't add any with statements yet.
They're all in the file, I had to,
Oh, then they should be commented out.
yeah.
So if you have with statements, comment them all out, and then rerun it. So you can comment them out just by putting an exclamation point. We're going to add them back in anyway. That was just me working through this before class to make sure that it all worked the way that it's supposed to. So let me know when you are at 129 degrees of freedom and a chi-square of 488. We're good back there? You have what?
130. Yeah.
I do too.
I also have 130 with
Let me make sure that I have all of my with statements commented out. GSC by, this by, that by.
Yeah. Oh, because I don't want to. It just shows, it just tells you which. It doesn't have students. Yeah, it just shows you how.
All right, who's got 130?
I did. I think so. I had these two on.
No on statements, just the measurement model. If we have an on statement, then you're not doing a measurement model anymore, right? All right. Run this again, and now is everybody at 129 and 488? Okay, 129 and 488, reasonable fit. What is the next step for a measurement model? What's the next thing that we want to do? Why do we add those with statements? You guys saw a bunch of with statements that I told you to comment out. Why would we add those? Yeah, and how do we determine if we should add those or not? What do we check? So let's look at our modification indices. And let's say that modification indices greater than 20 are going to be freed. Only with if they are within the same latent variable, which is the rule that we've been operating under, right? So the first one that we see right here, AP blackout with AP self-control or self-something. I think that's self-control. Those are two different alcohol problems that are commonly related. If you don't have any self-control, you're also more likely to black out when you're drinking, right? Let's go ahead and add that one, rerun our model. We're going to have 1 degree of freedom change. We were at 488, which means if our chi-square drops by 3.84, we will have, we'll just call it 4. So 488, if our chi-square is now 484, then we know that that model improved significantly, right? Our chi-square is now 448, so that it dropped quite a bit. How's our model fit looking now? Who has 448 and 128? Who does not have 448 and 128? Who has not run a model yet? We'll wait for you.
It's a lot of scrolling down.
There is a lot of scrolling down. 128 degrees of freedom. Chi-square of 448. All right. Anybody else not been able to run their model? What are we going to do next?
Look at the modification.
Yeah, let's check our modification indices again. We're looking for modification indices greater than 20. Only in the with statements, not in the by statements. We have one right here greater than 20. Blackout with physical dependence. That also makes sense. The modification indices greater than 20 to see which with statements we should add. So this with statement makes sense. Blackout with physical dependence. It's 38, which is greater than 20. We have another one down here, but we're not going to add that yet. We add them iteratively because they change. Blackout with physical.
That one and not the one with like 49.
Because the 49 is a by statement, not a with statement, right? You guys have a with statement with
I
a.
see if you blackout with ALC.
That's across latent variables.
Okay.
So we're doing it within latent variables. So if it's ALC, then that's alcohol, right? Did you say ALC? Yeah. So that's correlating a indicator with the ALC latent variable.
Oh, that's the one.
Yeah. So we're going to go AP blackout with phys-dep. We're going to save that. Again, we were at 448. Assuming it drops by 4, then we can call this a better fit and move on. 448. If it's less than 444, then we should be good to go. It is way less than 444. It's 404, so it dropped by 44. Model looks good. Starting to look pretty good, right? Let's check our modification indices again. And we have one right here, present time perspective with poor delay of gratification. Those are within the same latent variable. If you have poor delay of gratification, you also tend to be very focused on present time. That's not just related to impulsivity. There's underlying meaning there that has to do with time perspective. We can justify that as a correlated error, right? So let's go back. Let's add that correlated error. Hit save. Let's run our measurement model again. We were at 404. That means if it's 400 or less, then we know that it fits better, right? I'm just saying I'm just rounding our 3.84 up to 4 just for the heck of it. In truth, we're using MLR, which means we can't use the traditional chi-square test. What do we have to use in order to test these models against each other? Satora-Bentler chi-square, right? Yep. What I would do, though, is I would not do this with each one. I would iteratively add these, and then at the end, when I'm done, I would do a chi-square test of the initial model with no correlated errors and the final model with your correlated errors, and use a Satora-Bentler chi-square test to compare those two. And so I think that we are going to add 4 or 5 correlated errors here, which means you're going to have a degree of freedom difference of 5. And so you can still do a chi-square, a Satora-Bentler test with 5 degrees of freedom difference, and you'll just put in the 2 chi-squares that you've got, right? It was 404, it's now 378. That means it dropped way more than 4 chi-square values again, right? Model converged okay. Fit is continuing to look a little bit better. Let's check our modification indices again. Do we have any above 20? Yes. AP self P with AP control. What do you know? It's the next one in the list here. We're going to run this again. What were we at? 378. So now, as long as it's 374 or less, we know it's going to fit better. We scroll down. Model terminated normally. 356. It's less. Let's check our modification indices again. We have one more, AP risk with AP self-control. These are risk-related alcohol problems. And again, we see, look at there. It's like I'm psychic. All right. We should not, well, we'll check our fit. Model estimation terminated normally, that's good. Chi-square is 333. Does anyone have anything different from 333 at this point? You do, Richie? Is that
I do.
who? Oh, okay, you said it. 378. What's your degrees of freedom? Yeah, you haven't freed all of the. Go back and free all of those with statements. So we should have, is it 5 with statements now? Is that right?
At 125 degrees of freedom.
Then you haven't freed all of your with statements.
You did.
Do you have all 5 of those?
Yes.
Are you sure?
The ons again.
What? You have an on statement in there?
Yep.
Ah, remove that on statement. You don't want that. If you have any on statements, they should be commented out. Okay, is everybody at 124 now? Who is not at 124? David, are we good now? Yep. Are we all good? Who does not have 124 with a chi-square of 333? Nobody? We're all good? We good over here? I'm going to assume that we're good. Yeah? Okay, so we now have our measurement model. We want to specify this model We're not going to worry about this path just yet. So this is the model that we want to specify. Good self-control, poor self-control, predicting alcohol use, and then alcohol use predicting alcohol problems, and then both of these things predicting alcohol problems. Do we compare our measurement model to our structural model? No, there's no need to compare our measurement model to our structural model. We've set the measurement model. We know that the measurement model is good. So now let's specify our structural model. This is how we think that the measurement model fits together, right? We have poor self-control and good self-control on alcohol use. Poor self-control and good self-control on alcohol problems. And the partially mediated alcohol use on alcohol problems. That is this model right here. 1, 2, 3, 4, 5 paths, right? And I have specified 1, 2, 3, 4, 5 paths. I also named these B1, B2, B3, B4, B5. We're going to come back to that. You don't have to name them right now if you don't want. It's completely up to you. So it is helpful to get in the habit of naming your paths in M+. And you'll see why in a little bit. But for right now, just know that if you name those paths, you can then use them for other types of things, and you can do all kinds of cool, tricky stuff. Let me know, does everybody have their structural model specified? Not yet. Does anyone have their structural model specified? All right. And how'd it come out? What's that? Oh, you haven't run it yet? Go ahead and run it. Specify your structural model and go ahead and run it. And so I named these B1, B2, B3, B4, B5. You can just name them A, B, C, D, E, F, G, or you could name them 1, 2, 3, 4, 5, 6, 7. You can name them a bunch of different things. Actually, I don't think you can name them numbers. You might not be able to name them numbers. You might have to name them letters. This also can be helpful if you are doing a multi-group analysis, because then you can specify that path A in group 1 is the same as path A in group 2. Gosh, maybe next year I will teach multi-group. I just feel like we haven't gotten to that. I just haven't had enough time. Sorry. All right. Everybody got their structural model specified? Who does not have their structural model specified?
Can we take a look at the model?
You want to see it again? And by the way, in your homework this week, I did put the model in there. It's going to be basically the exact same model. You don't even need to take a picture of it if you don't want, because it's saved already but you can go ahead. I mean, I'm cool with that. But it is already saved in there for you.
Just to keep track of
Sure, the paths, what's going on, yeah. In your homework, you'll want to build this model and add your path coefficients. I think I said specifically in the rubric, make sure that you include a figure with path coefficients and an interaction. Okay, so we've got this model specified. Let's run it and see how it fits. Just real quick, let's have a look at this. Here's our basic kind of latent variable model. Have good control, self-control, both predicting alcohol use, and then both predicting alcohol problems and alcohol use predicting alcohol problems. I actually was not going to teach latent variable interactions today, but I got an email from a student who's doing latent variable interactions for their thesis and needed to know how to do it. And so we're doing it today. And actually, it's really cool. I mean, a lot of people don't know how to do latent variable interactions and certainly don't know how to probe latent variable interactions because it's far more complicated than what we've been doing before, where we just say define and then add whatever value, right? So this is going to be different. Anyway, here we go. We scroll down. And model estimation terminated normally. That's good. That's what we want to see. Model fit is 333, 124, 0.056. There is our measurement model. And we see that when it comes to predicting problems, good self-control does not predict problems at all. That means it is what? The relationship between good self-control and problems is likely fully mediated, right? Poor self-control is positively associated with problems. And wouldn't you know it, the more alcohol you drink, the more problems you have. When we look at alcohol use, we can see that poor self-control, how impulsive you are, is positively associated with use. So that relationship is fairly weak. Good self-control is negatively associated with use, which means the more effortful or good self-control you have, the less likely you are to drink, or the lower amount that you drink. And we have a correlation between good self-control and poor self-control. You might expect that that would be that would occur. This is not a standardized value, so it's difficult to understand what that is in terms of correlation. We did request standardized values, so we can scroll down here, and we can see that the correlation between the two is minus 0.44, which means that they account for how much variance in each other. No. Did you scroll down to the standardized? Because I just scrolled down to standardized.
Well, both my assumptions
Oh, that's not quite right then. This is 16%. I mean, you square that. Can you tell me how many degrees of freedom you have and what your chi-square value is?
125.
You're missing something. Let's flip back over here. Here's the structural model. What are you missing in the structural model? Should have 5 paths.
Yeah.
You do have 5 paths?
Yeah.
And do you have 5 correlated errors?
Yeah.
And you both have the same thing?
Wait, does it make a difference if there's an MOD 3.84?
Say that again. Oh, no, that doesn't matter. Who else? Okay, hold on. Let me look at your input. If you're going to name a, notice that all of my lines up here, prob on out, you can only put one predictor variable, one outcome variable if you're going to name that path. If you have 2 predictor variables in there, it won't work quite right.
So, before we had it like that, those are the ones that were in the file. So, if it was like this, then do I just take out?
It can't. If you're not going to name the path, then you can do it that way. If you do it that way, or any of it will only sure that it looks right. 125. Is 125 not 3/4? Is 125 the correct number of degrees of freedom? Is it 127? Can we close these out? Let's go back to your.
Journals. Why would they then make extra effort? Your plan falls apart.
There we go, 124 to 333. Does everybody have 124 degrees of freedom and chi-square value of 333? Yeah? Okay, so our model fits okay, right? We have all of our paths specified. Our model looks good. The way that you can make sure that you're always putting in the right model is you should always draw it out before you actually do it, right? Draw out your model, then put in your statements, then go and put your coefficients in for each path in your model. And if your model in M plus does not match the model that you drew, then you know that you've made a mistake. If you run into a spot where there's a path but no coefficient to go on it, then there's something wrong in your M plus code and you have to go back and work your way through it, right? So there's a little bit of troubleshooting that goes on with this. All right, so we've run a structural equation model. The model fits pretty good. What's our next step? We did a measurement model. We then took that measurement model and made it the best measurement model that we could come up with. Then we specified a structural model. We ran the structural model. We get a good fit for that structural model. Now we want to know something, right? What do we want to know?
Do we look at indirect?
No. We don't have to compare those two because your measurement model is nested within your structural model. And in fact, because we've added 5 paths and there were 5 correlated errors, you're going to have almost the exact same value, if not the exact same value, right? Say that again.
Indirect.
Indirect effects, our direct and indirect effects. Now in the past, we've calculated direct and indirect effects in a very simple way. How did we do that in the past when we were doing straight path analysis? Multiply A times B, and you can go back and you can do all of that. I've never showed you how to do that in M+, but there's a simpler way in M+, right? What's the simple way? We can add a statement called, say that again? So we can do bootstrapping.
We put IND.
Yeah, we have to put the IND, and it goes under its own unique heading, which is what? Model indirect, that's right. So let's go back and let's do model indirect. Is it in your model already? Did I leave that in or did I comment that out? Okay, good. So if I scroll down here, not that, right there. This is what model indirect should look like. So you can add model indirect, disregard this for right now. We're going to throw in model indirect, problems, and GSC. And this is going to give us our specific indirect effects as well as our total effects, right? So for good self-control, we'll have an indirect effect through alcohol use. That's our specific indirect effect. And then we will also have a total effect, which is our specific indirect effect plus what? It's our specific indirect effect plus our total effect, right? And I can show you, we'll look at this real quick. After we add that statement, we hit run. And should we have changes in model fit? No, it should not change a bit, right? So we should have 124 degrees of freedom and 333 chi-square, and we do. All of these things should be exactly the same, and all we're doing now is getting our model indirect. Here's our standardized. There is our variances. This is very important. We have a variance for our latent variables of 1. So in M+, I'm just going to say this now, and I want you to register it and then not worry about it. But M+, latent variables have a mean of 0 and a standard deviation of 1. Even when you've set the scale to be something else, the mean of 0 and standard deviation 1 holds constant. I'm sorry. It's my lab telling me stuff. That's going to be important. If your variance is 1, what is your standard deviation? What is the relationship between variance and standard deviation? It's 1. Yes, thank you. What's the relationship?
Square of the variance is standard deviation.
Yeah,
divided
yep.
by minus
Yep. So it's just 1. If your variance is 1, your standard deviation is 1. This is going to be important because in a moment we're going to probe simple slopes at plus and minus 1 standard deviation, right? So our variance for our latent variables is 1. Oh, I'm sorry. That's our standardized variance, though. But anyway, we come down here and we have our indirect effects, right? Our indirect effects from good self-control to problems. We have a total indirect effect of minus 0.352. That's through alcohol use, right? And then we have a direct effect, or a total effect of 0.503. And that is just adding these two together to get the total effect. Similarly, we have an indirect effect from poor self-control to alcohol use to alcohol problems of 1.27, and that is statistically significant. And then we also have a direct effect from poor self-control to problems of 0.292. That means that the more poor self-control you have, the more problems you have. Make sense? All right. Now let's do something tricky. Actually, what time is it? Yeah, we got time. This is our model. We have these direct effects to alcohol problems, these indirect effects through poor self-control or through alcohol use to alcohol problems. And now we want to add an interaction. Let's say that good self-control not only has that effect, but it also affects the relationship between alcohol and problems. That is, the more good self-control you have, the less alcohol predicts problems. It turns down the volume on that relationship, right? That is a moderation effect. And if it turns down the volume on that relationship, it will also turn down the volume of this indirect effect, right? Now, you could say, what about turning down the volume on this indirect effect? And there have been a number of simulation studies that have shown that it is inappropriate to model this relationship if you're moderating this variable. And the reason is because as this increases, this decreases, and you will get a floor effect or a ceiling effect, one way or the other, and it makes the interpretation of this fuzzy, right? So it's been recommended that you don't try and probe that interaction. And in fact, we can do it, like mathematically we can do it. You'll see that theoretically it becomes incoherent or not. I mean, it doesn't make good sense. Because let's do the math on this real quick. Let's say that good self-control makes this slope smaller, right? So if this slope right here is 0.5 and this slope is minus 0.2, actually let's not use points. Let's just make it simple. This is minus 5 and this is 2. Let's say that this is minus 5 and this is 2. What is the indirect effect here? It's just minus 5 times 2, it's minus 10, right? Now, if this makes this slope less, then let's say that at 1 standard deviation, this makes this minus 1 instead of minus 2, okay? So now we have minus 5 times 1 is what? It's minus 5 still. Before we had minus 10, and now all of a sudden we have minus 5. It doesn't make sense that as good self-control goes up, the relationship, that indirect effect gets smaller. But that's what it's showing, right? It went from minus 10 to minus 5. And so it's just incoherence. It doesn't make sense to do it. And there's a couple of, and if you shoot me an email, I can send you the papers. I actually had to, I was working on a paper like this and then found that I shouldn't be doing it at all. So And it was like really like frustrating as I like worked my way through this, and I was like, why is this happening? This should not be happening. This is a protective effect. Why is it weakening this other thing? And it's because when those two things are in the model together, they don't make sense. So, all right, we need to add this interaction effect. And the way that you add an interaction effect in M plus is by using a statement called X with. So we're going to rename or name a new latent variable called GSC alk. And GSC alk is the interaction of good self-control with alcohol use, those two latent variables. This is not named where do we usually name new variables at? We usually name them in define, right? But you can't name latent variables in define. So latent variables get named in the model statement using a by statement, right? Or in the model section using a by statement. We've added all of these up here using by. I'm going to move this back up. But we can't use by to make an interaction. You can't do GSC ALC by GSC ALC because M plus won't let you. It would be nice if M plus would let you do that, but it doesn't. So you have to use an X with statement. You can only use this with two variables. You can't put X with, X with, X with, X with, but you could do GSC PSC line, GSC X with PSC, right? Then you could do GSC ALC line, GSC X with ALC, and that creates two latent variable interactions, right? Because it's possible that you want a three-way interaction. Then you would do PSC or ALC line X with PSC ALC. Now you've got those three higher order two-way interactions that you need, right? And then you can add the single three-way interaction, which would be like PSC, ALC, GSC, line, X with, add either one of the two-way interactions that you've created, plus an X with the single latent variable. Does that make sense? I'm just like, everybody's just staring at me like he's just saying letters. We don't need to worry about it right now. If you need to do a three-way latent variable interaction,
So on the left of the line, you're naming it. On the right, you're explaining it.
Yes, that's exactly right. Yeah.
So what's the difference between using a line and an equal sign?
You can't use equal signs in the model command. You can only use lines, bys, withs, or ons.
Okay.
So yeah. Also, if you're going to use a line for anything in M+, actually, before I say that, everybody have this in? Okay, let's do one more thing. Let's go prob on GSC ALC B6. Call it B6 down here. Let me see what I called it. Okay, do we have that added? Everybody got this added?
Sorry, the stuff that you scrolled down to?
Yeah, don't worry about that right now.
Okay.
So we created this, then we added B6, right? Problems on good self-control by alcohol use. Go ahead and hit run. Where do I have it in twice?
We got commented out in one place.
Oh, yeah, this is commented out. Sorry, I typed it out here. I could have just uncommented that. Let's delete that so it's not confusing. Okay, go ahead and hit run. And what do we get?
Mine said, like, I got some error message. It said type equals random must be included in
We should all have that error message. Where is it at? Here. We have to add type equals random. We put a line in there. And any time in M+, whether you're doing multi-level modeling or latent trajectory modeling, growth curve modeling, or latent variable interactions, you have to use a line. And that line indicates that we are using a random variable, and an interaction is a random variable. So we're going to go back and we're going to say type equals random. In the sense that it is the interaction of two unobserved variables. You can have a single unobserved variable that's not a random variable, but as soon as you have a formed like two latent variables, it becomes random. I don't know how better to explain it, unfortunately. All right, let's go up to our model command, and let's put type equals random. And let's hit run. Yep. This is in your model command, or I mean in your analysis command, sorry. Type equals random. And we hit run, and what's the next error message that we get?
So to put algorithm integration.
Yeah, so in order to run a latent variable interaction, you have to use numerical integration. You're going to find that this is common with latent variable interactions and also count models. If you have to run count models, especially nested count models, they require numerical integration. I cannot explain to you what numerical integration is. It is a maximum likelihood approach that does not give you, unfortunately, you will not get fit indices. So before we add numerical integration, let's talk about this. We have specified a latent variable measurement model, and it fit good. Then we specified a latent variable path analysis or path model structural model, and it fit good. And now we're going to add a latent variable interaction, and we are not able to examine whether or not it fits good or not. So how do we tell if this model is better than the model we ran before? We will not get a chi-square because with numerical integration, you get no fit indices whatsoever. You'll get one thing. Let's run it and let's see. So we add algorithm equals integration, hit save, and run. It looks like I might have another error here because that looked like it went way too quickly. Oh yes, and that's the last piece of this. We've been using model indirect because that's the easy way to get our indirect effects, right? But with numerical integration, model indirect doesn't work. We're going to have to figure out a new way to calculate our indirect effects if we're going to look at latent variable interactions. This is important because we're going to run into the same issue when we start doing multi-level structural equation modeling, right? We're going to run into this issue where we have to put type equals random, and with type equals random and numerical integration, you cannot get indirect effects. So let's close this out. Let's go back and let's comment out our model indirect. And then hopefully we will get this model to run. It looks like it's running. And this is what it looks like when it does numerical integration. It scrolls, it scrolls, it scrolls. And it's trying to maximize the likelihood, right? It's trying to get the absolute lowest likelihood that it can. So it bounces around, hits 89, and then it goes up to 90, and it says, okay, we need to start over. So here it's bouncing around, it's going up. Eventually it will stop because it wants to get down. The goal is to get to a lower number, not a higher number. And now it's working down. It's at 303. And down to 8. That looks like it's probably going to converge right around here. There we go. The goal is to get it as close to 0 as possible. Now we want to make sure that our model terminated normally, because we're not going to have fit indices to tell us if it fits good or bad or what. So we want to at least make sure that there's no real problems. It did terminate normally, and we have no error statements in here, so we're looking good. This is all we really have to go off of. It does not tell us what model fit is, but we can use this to compare it to our previous model. We're not going to do that right now. There is also another way to compare this to the previous model, and that is through a non-nested test, which we will talk about in a different class. We're not going to talk about it today, but you can do what's called a Wong test or a Clark's distribution free test. And with those tests, you actually ask M+ to give you the log likelihoods from your model, and then you can compare the log likelihoods against a chi-square distribution. The difference in log likelihoods against a chi-square distribution. So, but we're not going to do that today. We're not going to worry about it. I'm going to tell you right now, this model fits better. We scroll down here, and we have a look at our structural model, and we see that there is a significant interaction effect, right? We have a significant latent variable interaction. Fantastic. Doing good. What's our next step? Once we have a significant interaction, what do we do next? Probe our simple slopes at high and low values, right? All right, that's what we will do right after the break.